engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
Questions. Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to The Naked Scientists, the show where we bring you the latest breakthroughs in science, technology and medicine. With me, Chris Smith, and today, what role might artificial intelligence play in forthcoming elections? Also ahead, we assess the link between parts of the brain and your likelihood of getting hooked on cigarettes, and the red admiral butterfly population, in the UK at least, is soaring. But do we know why? Many of the world's democracies, including the US, the UK, India and South Africa, will be heading to the polls next year to contest crucial elections. It comes at a pivotal time in geopolitics, and with rapid advancements in artificial intelligence, AI, there are concerns being expressed about the role that technology might play, not just in political campaigning, but in influencing the outcomes of national ballots themselves. In a commentary penned for The Guardian this week, the Open University's John Norton highlights these worries, dubbing the situation social media on steroids, and without the usual telltale signs of human derangement or any indication that it has emerged from a machine. To discuss the implications with me are John Rosenbeek, who's a postdoctoral fellow at the University of Cambridge and also the author of the forthcoming book The Psychology of Misinformation, and Kate Dommett, who's Professor of Digital Politics at the University of Sheffield. John, let's start with you. Is there a distinction between misinformation and what we used to call propaganda, or are they just broadly the same thing?
That's a good question. I suppose you could call propaganda misinformation with a political slant, but oftentimes misinformation is implied to mean something that is false, contains a falsehood, whereas propaganda doesn't necessarily have to be false. There's many different ways to go about this definition, but that's the effective distinction. But in the modern era, these two terms are often used interchangeably.
And are they playing a more prominent role, do you think, in the modern era, Kate?
Attempts to mislead within politics are quite well established. What's new is the technology angle. We've had innovations in technology before, and it seems like each new piece of tech just brings a wave of new concerns about how we're being influenced in politics.
Are you not concerned about it then?
I am concerned, but I think it's important to be really clear about what we're actually concerned about. I think when you bring technology into it, it all becomes quite mystical, and we don't really understand the technology that is driving and making these decisions. But I think ultimately it's always humans that are making these different technologies and that are deciding to use them in certain ways. So I think my concern is about how are we holding those who are active in politics to account for their use of technology rather than focusing on the technology itself.
John?
I think a good analogy here is the rise of the radio in the 1930s, right? And the Nazi regime under Goebbels was, of course, the first to make effective use of radio to spread propaganda, but we don't blame the radio nowadays for the rise of fascism.
The role of AI, though, this sort of moves the game along, doesn't it? Because we've seen demonstrably with social media entering the fray around various transmissions of news stories and propagations of news stories, we've seen social media play an active role, a proven role, in influencing public behaviour around, say, anti-vax behaviour. When the financial crisis occurred in the late noughties, it possibly provoked runs on banks, for example. So are we into a sort of new regime now then, John?
It's a bit unclear. There was a study out recently in the journal Science Advances, which the top line of which was AI disinforms or misinforms better than humans. That's a bold claim to make, right? But the difference between persuasiveness of human-generated misinformation and AI-generated misinformation by ChatGPT was only 3%. And in both cases, humans were really, really good, 92% accurate and 89% accurate, respectively, at correctly identifying human and AI-generated misinformation. And so I'm not so sure if there's a demonstrable problem in the sense that it's worse. Also, because we have to bear in mind that even if the misinformation that we see online is AI-generated, that doesn't necessarily mean that it makes its way around existing content moderation practices, right, that tech companies have in place, for instance.
Point taken. But there was a paper that came out from the University of East Anglia this week, and I'll quote the authors, who said, ChatGPT presents a significant and systematic political bias towards the Democrats in the US Lula in Brazil and the Labour Party in the UK. What they're saying is that if you ask this thing questions, you get politically biased answers, but they are loaded towards the left. As an extreme example, someone asked it the question, would it be better to make a racist remark or a nuclear war? And the ChatGPT said, well, a nuclear war is better than a racist remark. It's obviously not. I mean, it seems that it puts offence of a few people over the deaths of millions. Do we really want this, Kate, influencing political decision-making?
Well, do we want to? I think that's the question. I think, that study is really interesting because it shows that the way that you train these AI tools affects the kind of outputs that you get. And there's been a wide range of studies about the kind of biases that exist in the online world and the way that we as kind of humans program systems result in systematic biases in the way that the tools work. So there've been a number of really interesting studies showing that apparently neutral technology does have these political biases. Now, I think that is a really interesting question because a lot of our principles around how democracy and elections work are there a kind of equal access, that everyone kind of has the same chance to be heard, that you spend the same amounts of money and get the same service. And we often don't know how these different technologies are working and whether they do contain biases. So for me, that's the real issue of concern, is can we as researchers, but also as members of society, understand the technology that is, the way that the technology is working, and if there are biases or not within that tech.
One thing to add perhaps is from that study, which I really liked reading, OpenAI, which runs ChatGPT, is a company, right? And so they're concerned about their reputation themselves, which means that they hamstring, if you will, ChatGPT manually and allow it and disallow it to say certain things, right? We don't really have a lot of insight into what exactly they do to moderate what ChatGPT puts out. But it would be bad for their reputation if ChatGPT were to, promote racism and so on. It's not only the training data that was used that might be biased in some capacity. It's also these kinds of drivers that need to be taken into account. So I'm not necessarily sure if it's the AI itself that we're talking about here, or are we having a broader debate about politics?
And just briefly, Kate, do you think we're at the stage where AI could be used to have a meaningful impact on things like election results?
A lot of the research that I do looks at what political campaigners, so political parties and non-party campaign groups do in elections. And from the interviews that I've been doing with kind of parties around the world, they're not in a place to be able to use AI yet. So, parties themselves often don't have a lot of people who work on this stuff. They might have one person who does quite a big range of tasks in terms of producing campaign materials. So they're not really in a place to adopt this yet. But I do think we're going to start to see AI be used. It's going to appear there's going to probably be examples of deep fakes or kind of manipulated images. And that itself shouldn't be underplayed, because I think the isolated examples of these things that do come through and do break through into discussion really help drive debate. The concerning thing for me is that it makes it hard to work out what to trust, and that's the issue.
Kate Dommett there, and before her, John Rosenbeek. A new study by university researchers in Cambridge, Warwick and Fudan in China has found that levels of grey matter in the brain's frontal lobe, where we make decisions and decide whether or not to follow the rules, is linked to an individual's likelihood of taking up smoking during adolescence. Professor Trevor Robbins is from Cambridge University's Department of Psychology, and he's the study's co-author. He's been telling me all about it.
The adolescent brain is in a very plastic and developing stage. It's very vulnerable, actually, to nicotine and its effects. And so if you start smoking, then the chances are that you will continue smoking as an adult. So what we did was to rely on this fantastic Horizon study with European labs, where we screened 2,000 14-year-olds. We measured their behavior and their attitudes, including their smoking behavior and their attitudes to that. And also we scanned their brains, not only at 14, but also follow-ups at 19 and 23. And one of the main findings of the paper is that for those adolescents who were smoking at 19, already by age 14, there was a change in their brain.
And critically, Trevor, you're saying that at 14 they weren't smoking yet.
Exactly. They weren't smoking yet, but they came to smoke after 14. But at age 14, they had a loss of grey matter in the frontal lobes, which are those structures just behind the eyes in the brain, grey matter being nerve cells. And that occurred before smoking. And the degree of loss of the grey matter correlated with how much later they became smoking, as it were.
What does that bit of the brain do we think? And can we square that with why this might be happening?
Yes, we can. That's a really key question. So what we did in this study is we gave a number of questionnaires, and one of the questionnaires was actually about rule breaking. Do you have a tendency to break rules, to be unconventional and not do what the norm does, and maybe disobey your parents or your teachers or whatever? Those questions correlated with the loss of grey matter in the left frontal lobes. Now, there has been a report in the literature about this in brain damaged patients who have damage to the left frontal lobe. They have a problem with rule breaking. So we kind of found results which agreed with that earlier study and provides us with a behavioural mechanism for understanding why they may be smoking earlier, because maybe they're just going against what their parents and teachers say.
Are the changes focused just in that part of the brain, or do you see changes elsewhere? Because, of course, different areas of the brain are all talking to each other. They're connected. And so, therefore, what happens in one place does influence elsewhere as well. So do you see any knock-on or secondary changes?
That's a very good question. So the first point to make is that the left frontal cortex is quite a large area. There are different bits of it which probably have different functions. But among those functions, adhering to rules may very well be one of them. It's also true that these parts of the brain are connected to other regions of the brain, which we know are involved in addiction. So a very important connection is to the structure called the striatum, where dopamine has an important role in reward and so-called reinforcement mechanisms, which are a very important part of addiction and how drugs manipulate systems to produce addiction. So I said earlier, the fact that nicotine is working on the adolescent developing brain probably is another very important factor.
It sounds then, from what you're saying, like there's a sort of 1-2 punch going on, where we have a predilection to break rules and therefore render one susceptible behaviourally to trying a tobacco or nicotine-laced product in the first place. And that could be cigarettes or vaping, presumably, in this era. And then there's a secondary effect, which is that the nicotine itself then almost reinforces the situation because the brain is vulnerable to and susceptible to the effects of nicotine that then entrenches this.
Absolutely, Chris. And actually, there is a second part of the story, which is interesting. And it's this, that the left frontal lobes may be involved in initiation, but once you've started smoking, it seems that the more you smoke then, the more there's an effect on the right frontal lobes. And the right frontal lobes are involved in the enjoyment aspects of sensation seeking. So they're probably involved in controlling the circuits which depend on dopamine, which nicotine works on initially to produce the hit. And so the second part of this story is the development of nicotine addiction, the reinforcement, the maintenance of smoking, which may depend on nicotine itself or something to do with smoking having some toxic effect on the right frontal lobes and actually reducing grey matter there as well.
Trevor Robbins there, and he's just published those results in Nature Communications.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
You're listening to The Naked Scientists with me, Chris Smith. Still to come, we'll find out why the UK's red admiral butterfly population is thriving. But first, The sound of the launch of Luna 25, which is Russia's first mission to the moon in almost half a century. Moscow is going to become the first country to land, they think, on the lunar South Pole. But why does this matter and why are they doing it? With us now to explain is space scientist and author Dr. David Whitehouse. What can you tell us about the mission, David?
Well, it's, as you say, the first Russian mission to land on the moon for 50 years. It's been a long time coming. There are major components of this lander which are decades old. And in fact, the propulsion system was put together 6 years ago, has been waiting for the money and the effort to come together to launch this. But launch it they have. It entered lunar orbit yesterday, I believe. And on Monday, if all goes well, they should be landing at Boguslavsky crater, which is near the south pole of the moon, just 2 days before the Indians put their craft in a nearby region not far away. So exciting times for landing on the moon.
It sounds like a space race, but this time India, Russia.
Well, India has been planning this for quite a few years because they did try in 2019 to land on the South Pole with their Vikram lander, and that crashed. Indeed, Israel, India, Japan and the United Arab Emirates have tried to land on the moon in recent years, and they have all crashed. So India is returning and has hopes for exploring the South Pole of the moon quite intensively, along with the United States, which is going to send several probes to that region. Russia is a bit slightly different in the sense that Luna 25 took a long time to get off, and it remains to be seen just how they can follow it up. Or they want this mission to last a year on the moon, which would be extraordinary. It remains to be seen how many subsequent missions they've got. But if they do achieve the feat of the first to land at the South Pole and dig into the lunar dirt and analyse it for ice, that would be a major achievement, and they'll be pleased about that.
What are the main goals of the mission, apart from looking for ice, presumably, because that's a source of water, and if we want a base on the moon, that's a prerequisite?
Well, that's right. The South Pole is going to be the place where all the action is on the moon because of the ice which is there, and because it's possible to get, in certain regions, solar power the whole month long. If you have a base at the lunar equator, then you have 2 weeks of light and 2 weeks of darkness, and that gets very cold in the darkness, and you don't have access to this water resource. So if they can make the first measurements, they've got 6 or 7 very sophisticated bits of kit on board the lander, and they're going to scoop up this soil and they're going to analyze it. And they should give us the first real close-up hard data of what is actually at the South Pole in the soil, because prior to this, we've only had observations from satellites in orbit. So that would be a major scientific achievement. They would be very pleased. But there are going to be, over the next 18 months or so, building up to the human landing, there are going to be probably 8 to 10 missions going into this region, making various kinds of measurements themselves.
Because NASA have got their Artemis mission heading there. Is that all going to plan? Because that is the aim of having a human on the surface of the moon pretty soon, isn't it?
Well, the plan was for 2 people. For 2025, there was a mission in 2024 where a crew of 4 would fly around the moon, and then they would land on the moon a year later. That's slipping slightly, perhaps, because it's likely that Artemis 3, the first lander, would actually become an uncrewed mission, and Artemis 4 might be the lander. And the problem with that is that the actual landing craft, which is to go on the moon, is to be produced by Elon Musk's SpaceX, their Starship. And this is a very impressive craft if it works. And it hasn't worked so far. They've had one big test, which was a major disaster. It blew up very quickly after taking off, and they're investigating that, and the rumor is there'll be another test within a few weeks or so. But they really have to get that working properly in order for NASA to have confidence that they can put their astronauts down on the surface of the moon, and that is not there yet.
David Whitehouse there. There's been a sharp rise in the number of red admiral butterflies in the UK. The charity Butterfly Conservation has enlisted the help of the public to help count them, and they think there's been a rise of more than 300% on the last year. Zoe Randall is the Senior Surveys Officer at Butterfly Conservation.
What we've done is we've enlisted the help of the general public. We've run the Big Butterfly Count. It's the largest annual citizen science project on butterflies in the world. And we've had over 125,000 counts submitted by almost 90,000 people. So thanks to everyone that's taken part. And they've counted in excess of 247,000 red admiral butterflies.
So people just go out in their garden or in their nearby park and they're totting up how many butterflies they see in an hour or something. Is that how it works?
Yeah, well, it's not even an hour. Anyone can take part. It's dead easy. All you need to do is spend 15 minutes in a warm, sunny spot and count the different types of butterfly that you see. There's an identification guide on the Big Butterfly Count website that people can download to help them identify the species that they see. And there's also a mobile phone app as well, Big Butterfly Count, that's got a built-in ID guide, and you can log your counts there or on the Big Butterfly Count website.
So 2 questions we need to explore then is, one, first, why the red admirals have shot up so much, and then what's happening to the other species. We'll look at that second. So tell us about the red admirals first. Why do you think they've gone up so much?
Well, the red admiral is traditionally thought of as a migrant species. It's a sort of summer visitor to our shores. Normally lives in the Mediterranean and North Africa, and they've evolved a survival strategy which helps them track their food plant. So they will move into areas where their food plant is more abundant to escape the summer droughts that are coming in their native lands. But more recently, the red admiral has been found to be breeding in the UK, and it can survive our winters. So the long-term trend for this butterfly from the UK Butterfly Monitoring Scheme is an increase in abundance of 234% and 15% in distribution. And we believe that climate change is driving the increase in numbers that we've seen in the UK this year.
Where there are winners, there are inevitably losers. Does this mean that some other species that perhaps rely on a cold snap are not doing quite so well?
Yeah, that's absolutely right. So climate change is beneficial for some species and detrimental to others. So, for example, in Scotland, we've got the Scotch Argus butterfly, and as the name suggests, it's primarily found in Scotland. There are a couple of sites in northern England, but what we're seeing is that the butterfly is trying to escape the heat, and what it does is it shifts its range northwards. So it's moving further northwards in Scotland and retracting from those southern ranges, and it's also going up to higher elevations as well to escape the heat. So once you get to the north coast of Scotland, there's not really anywhere for you to go, and once you get to the top of the mountain, where does the butterfly go? So so it's a mixed bag. And also, climate change is beneficial for some species. It does enable them to move northwards, but to habitat specialist species, for example the Duke of Burgundy, the pearl-billed fritillary, they can only move northwards and take advantage of climate change if there's suitable habitat in the new sort of envelope of places that open up to it.
Zoe Randall there. Well, now it's time for something completely different, and I'm going to hand over to James Titko for our question of the week. He was joined by Phil Broadwith from Chemistry World magazine.
This question comes in from Christy. She says, I was stirring some sugar in some water the other day to feed my bouquet of flowers, and it occurred to me that sugar would dissolve faster in hot water. Why do powders dissolve faster in heated liquids? Another example I can think of is Jell-O powder, which wouldn't dissolve at all if your water isn't hot. There's a little bit to unpack there, Philip. Let's take the first part of the question. Why do solid sugar granules dissolve faster in hot water?
Okay, so the thing that you've got to work out is sugar is a relatively small molecule, and inside a granule of sugar, there are lots of those molecules packed together, and they have bonds or interactions between them that are holding them together. To dissolve it into the solution, what you need to do is separate all of those molecules out from each other, so break those bonds holding the molecules together and replace those with interactions with the solvent molecules. Water is quite a good solvent for sugar. It will dissolve relatively easily, but the more energy you put into the water, so the hotter you make it, the easier it is to break up those bonds that are holding the sugar molecules together, and the faster the molecules are moving, so the more times they'll collide with each other, the more opportunities there are to transfer that energy and make that dissolving happen.
Christy suggests correctly that sugar will eventually dissolve in cold water. It'll be slower, but it will eventually dissolve. Whereas with a different solid, Jell-O or jelly, it will only dissolve into the solution if there is enough energy in the water, if there's enough heat. What's the difference?
Okay, so sugar is quite a small molecule and it's quite soluble in water. Jelly is a much bigger molecule. It's actually a protein, so its chemistry is quite different. The way it interacts with the solvent, the water, is a little bit different. But mostly it's because it's a much bigger molecule, and those big molecules have a lot more bonds between the molecules. So it's much harder for the water to break them apart. It takes much more to get in between the chain, the gelatin protein, to break them apart and dissolve them in the water. In fact, they never really truly dissolve in a sense. They make what's called a gel or a colloid. That's how jelly is happening. When it's warm, it behaves kind of like a liquid. It's sort of like a solution. But as it cools, the chains, the proteins start to stick back to each other and try to make a solid. But in doing so, they trap water in between them. So instead of making a kind of dry, powdery solid, they make a gel or a jelly.
Thanks very much to Phil Broadwith from Chemistry World magazine. And that's all we have time for. But on Tuesday, we'll be taking you on a gastronomic journey to find out what makes a meal healthy, tasty, and sustainable. The Naked Scientist comes to you from the University of Cambridge's Institute of Continuing Education. It is supported by Rolls-Royce. I'm Chris Smith. Thank you for listening. And until next time, goodbye.